Hello, welcome back to LeetCode Daily Live, where I do the LeetCode Daily question raw and uncut. So let's get started. Right, so after a lot of mediums, we finally have a hard. So let's see what we want here. So shortest common supersequence, maybe DP. Wait, let's look at the bounds. Yeah, it could be a n squared DP, like just by looking at the bounds. So given two strings. So two strings, return the shortest string that has both string 1 and string 2 as subsequences. So subsequence is like, it doesn't have to be contiguous. If there are multiple valid strings, return any of them. Right. Is that DP? Let's think about it. It could be DP. Yeah, so the question is pretty straightforward. Like, you just want to find one string that, has, like, both string 1 and string 2 as is, like, subsequence, right? So, yeah, maybe it is not DP actually. But let's think about it first. So one way to do it is, like, we can do AB, ABAC. So we can have one string there first, maybe. And then so what, like, we know that like the output has to contain like one of the strings, and then we just have to add characters like here and there, and we want to find like the best place to do it, I guess. So maybe it is DP. So in this case, first of all, you can, like, you want to reuse the characters as much as possible, right? So, like, if we are looking at string 2, like, we will be looking at, CAB, so like where we can put these characters, right? So we really have two options. Well, the first option is, like, we can put it at the front. Well, putting it, like, anywhere here, like, between any of these gaps, are not going to be useful, because, like, putting it at the front is strictly better. The other option we have is, what happens if we put, like, if we just use the existing C here. So, that could also be, so I think we have, so we have, like, many choices for each character. So the first choice is, the first choice is we can put it at the front, or like whatever the first, like, whatever the first, oh wait, I had to correct myself. There are only two possible optimal choices. So the first one, putting it at the front, and you might be like having, like, let's say when we were looking at A, like, and we put a C here, we might want to put an A at the front as well. So when I say the front, I mean like as leftmost as possible. Uh, like considering all the strings, like the substrings before that. So that's one thing. So, like, if we look at, like, C alone, so first case, put it at the front. Second case, we can just use the C, like the first existing C. So why don't you, like, what if we have more C's afterwards? If we have more C's, it's still better to use the closest C, right? Because if you use, like, the next C, by exchange lemma, like, choosing the first one is better. Like, basically that means, like, it's more optimal to choose, like, the first one. Yeah, so we have two choices. And then for these two choices, the question is, like, because we have 1,000 characters here, but each of them has two choices. So like, how are we going to you know, like when we choose A, like we might have like even more options already. Um, hmm. So maybe it actually does involve some kind of DP. Um, this question is pretty tough. Let's think about it. Um, so so let's look at the first case first. So if we put a C here, that means like I think we should have a count as well. So like that would be how many characters we have to add. Um, so if that's the case, how many characters we have to add? Yeah. So what if the DP table has like the number of characters that we have to add? So that would be at most 1,000 because like string two is only like 1,000 long at most. And then maybe we can have like the number of characters covered. So that would be like CAB here. So um yeah, do we want to know the position of it as well? Um, do we wanna? Yeah, I guess like after we look at C, so like for this case, we know that like we have to add one character, right? So that means like here, like we have to add one character, and then um yeah, and then we can look at and then we can look at A. So uh probably should do this actually. Yeah, CAB. So like we could be using an existing C as well, right? But then maybe we want to store the position, maybe. So like for example, if we are putting C at the front, then we are adding one character, but then so we are adding one character, but then our position, like what like the available uh characters that we can use are still at position 0. So that means like we can still use everything else. So what if we store the what if the DP stores the position, and when you reach the end, so that means right. So that means like when you use the C here, so when you use C here, well yes, it is going to like give you well like uh yeah, so it it is technically like adding 0 characters. So this row would be like number of characters added. Um so 0 and C um yeah, okay. So yes, we don't have to add any characters. But then our position is going to move to, well, 0, 1, 2, 3, 4, right? It's going to, like, because we have used this C, we can't use anything from this point on. So, well, that no C is here, actually. So that means, well, we have reached the end. And what do we know about that? That means, um, if we, um, like if we are doing C here, like we would have reached 4. So that means for A we have to yeah, like we can't see any more characters there, right? Um yeah, so that means we have to like we are forced to go down and like put an A here. So from here, like from not adding any characters, we have to add an A here. But for this case, well, again, we find the closest. So like, yeah, so we have, like, if we do this, we are going to have, well, like 1,000 times 1,000 divided by 2. So that would be like 500k entries, right? Uh, so that means we can't actually do a linear sweep because that's way too slow. Like, but this is a very easy problem to solve. We can just have a map that has all the indexes. So like, well, ignoring this C, like you have A, B, C, and like you'll be 0, 2, 1, 3. So like this would be the indexes, and this would be like what character it corresponds to. And if we do that, we can just use bisect to find the closest, like starting from some number, like let's say like 1 or something, and like we want to find the closest A on the right. Well, if we start at 1, we can just do bisect left here. So like that's a very easy problem to solve. But let's think about the DP a bit more. I think it's very promising. Yeah. So from like adding a character C here, from adding a character C here, we can either add another A, or we can search for an A. So we have 2 paths again. Like we can go here or there. Yeah. So if we are just adding the closest A, well, this is like at position 0. So if we do bisect left, we can find that there's a 0 here. So that means like we only have to move across 1. And we, again, like the more left the position is, the more characters we have available, right? So that means it has to be more optimal. So what we want to do is we want to like get the minimum. So set it as 1 here. And then what do we want afterwards? We want to set it. Yeah, okay. The next thing we want to do is like we want to add an A like before here. So that means like we are still not using whatever character like we are on right now. Yeah, so that means like we are still on position 0. And then when we look at B, well, again we have different options, right? So we can either just look for the next B, which, well, it'll be 2 here. We'll look for the next B, or we can well, go from like adding a C, using an existing A, and then adding a B here. So that means using it as, yeah, so that means like the arrow will be here and we add a B. Well, it doesn't really make sense to add a B here, but like the position will still be 2. So, and well, this case, like you're just adding CAB at the front at this point. But then, well, you just want to find the first entry. So this represents number of chars added, right? So you just want to find the first entry that has a valid position. And I guess it is also fine to like have it at the end. So like if we look at the like this AAA, yeah, so these are like 8 A's, right? So like I'll just do 3 for now. Like so at the end of this like DP thing, like the optimal should have like 3 here, right? But basically that means that it is possible to like to not add any characters. So we can't really just fill all of the like all the DPs with like with the last position. Maybe we have to do infinity, maybe? Yeah, I think we have to do infinity. The other thing we can do is maybe we can have a map. Nah, I don't think. Yeah, I think a 2D array might be a bit easier to logic with. Um, yeah, the question is still like when we reach like the last position, what do we want to do? That means we want to search an A from like from 4 onwards, right? And well, it is not possible. These are the added characters, so it is not possible for any indices to have like a 4 or more index. So that means like it will never be able to go that way anymore. So it will like just like go down. Okay. Um, but then that means like on the last row, the last column, if we see like a 4 here, that means it is still possible. Like it just means that we have just used up the last character, right? Yeah, so we can just set everything else as like infinity or something. I'm pretty convinced this works, but let's code it out first. So we have yeah, so we want to fill in string 2. So we want string 1 string 1 string 1 index map. So we'll just do so what do we want to do here? I think just default date maybe. Yeah, import default date. We want a list, and then we just want for C in string 1. I see. We want to enumerate it because like we want the index, right? So we will just do string 1 index map of the character append I, and it will be sorted automatically because like the I is also like sorted here, so like it will go from 0 to whatever length string 1 is. And then we want to form a DP array, a 2D DP array to be more exact. And it should have, so what are the sizes? If we look at this here, so how many rows do we have? We have yeah, just a number of characters of like CAB, and then we have CAB on the side. Yeah, because like the maximum we can have is like the number of like the maximum we can add is the number of characters on string 2, right? But then we also have the 0 case, so that means it's actually like +1. So we'll have a length of string 2 +1. And then I guess we can have the position of the character instead. Would that be a bit better? Like instead of putting like CA and B here. Yeah, I guess the position would just work fine. So that means we want a structure that looks like this, right? So to do that, we just use list comprehension, of course. So in range 2 +1, well, and then here we just do we just define our infinity, I guess. Int 29, and then we can just use our infinity here. So infinity for in range string 2. So that's how we're gonna define our DP, and then we need the do we need a base case? Probably not, right? Let me think. So now we just want to loop like character to character. So I guess just do for maybe we do want a base case actually. So once we have reached the infinities, yeah, I think like we do want to generate like the current column using the previous column. So we do want the base case actually. So we'll go the first row. So what do we have? So the first row, first column represents using like the character. If it is not found, we will just go with infinity. Yeah, otherwise we will like get the position of the character and then we just, like go next. Oh yeah, actually what happens if you bisect left, but there's nothing more on that side? I think it returns like none or something, right? Actually I'll test it out right now. So what if I'm doing import from bisect, import bisect left, print bisect left. So if we are doing string 1 index map, there will be tons of A there. But what if we are bisecting with like 4? Yeah, let's just see what happens. Oh, we want to return a string. Wait, no module called default dict. Is that not how you input it? Pretty sure it's... Oh, because it's from collections. Import default dict. Well, in LeetCode you don't actually have to import, but it's just good practice, I think. Infinity can only concatenate string, not int to string. Where am I concatenating there? So we have a list comprehension in here for something in range length of string 2. Here. Oops. Okay, let's see what it prints. It prints 2. But that means that's the... Is it the last character? Wait, actually, do we even need bisect? We definitely do need bisect. Right, so it actually returns the front, the last element, right? Yeah, just doing a bit of experiment here. Right, and if we do 2, it should return 2 as well, I think. Yeah, because bisect left is lower bound. Wait, it returns 1 now. Oh, it returns the index. Oh, okay, yeah, it returns the index. So, like, obviously, if whatever it returned, like, is the length of the entire array, that means, like, that means it doesn't, like, it isn't valid. But in this case, maybe we have to loop through everything anyways. Yeah, anyways, let's get to the base case first. So this case, we just want to I think we want to bisect left first. So bisect left. So string 1 index map. We want the first character of string 2. And then we want, well, our current position is 0. So that's how we're gonna get the index. Yeah, I think so. This is going to print 1, right? Because we only have one C there. Huh. It prints 0. Oh wait, yeah, it does print 0, like, because there's only one element there. But like the element is like 3, so yeah. Okay, so we can find the index here. And so if we have the index, we actually still want like the actual character there. Yeah, so we can just do this actually. Yeah, so we can get the maybe we can write it in the function, right? So maybe we put it up here. So def get get position. Yeah, just do get position. What do we need? We need the char. Yeah, we need the char. So that'll be a string. In Python there are no chars. That'll be the string, and then we want the index as well. That'll be an int. That should return an int. So we can do this here. But then this of course could be bigger. So then we just want to do, yeah, we want to do C here, of course. So after bisect, so we want the, so this is the map index, right? So if map index is equal to the length of, well, our index map for that character, if it is equal, that means it has exceeded any of the possible positions. So we just want to return infinity, I think. Otherwise, we will just return this here. Yeah, map index. I think that works. So now we can just do dpc dp0. So this is the count. This is the count of characters that we have added. So we don't want to add any characters here. And what character are we adding? We are adding, well, the first character in string 2, right? So we want to get pos of the first character, and our index is at 0 right now. So we can get that, and then we can also like add one character in. Wait, this is, oh yeah, we don't actually need that. We want this instead, because like we are storing the position of the character, like how many characters we have looked at so far. Yeah, and that will be of course 0 because we are adding the C at the first character at the front, and now we have we should do for I in range. How many columns we have to look at? We have this many columns. So we just want to do like here, but -1, because when we are looking at the first column, we are actually doing the DP for the next column. So like when we are doing the second last, we will look at the last one. So we want to do this, and then what do we want to do? I think we want to loop through. We should use J for consistency, because J usually represents column. So for I in range, so that would be the length like there will be this length here, right? So we do have to go all the way to like to its length, like to the actual full length. Right. Yeah, and so if dpij is infinity, well, that means like it is invalid. It is not possible to form that. So you just continue. Otherwise, we do have a position like on our hands. We do have a position. Uh, so for each of them, there are two different cases. So dpij, you can look at dpij plus 1. So that will be finding the next character. And you can also look at dp I plus 1 j plus 1. So that will be like just adding a character. So actually this case is very simple. We just have to we're just adding a character, right? So do we have to make sure we don't fall out of bounds as well? So does that mean we don't actually want to look at the last like possibility? Is that true? Do we not want to look at the last possibility? Yes. Yeah, actually that's correct, because like it'll more or less form a triangle, right? Unless you have to like add all the characters in. So I don't know, if you have like AAA and then ZZZ. Yeah, so you have 0, 1, 2, 3. Of course you have to like none of these are possible. Well, like none of the horizontal ones are possible. So like so that won't be possible. So these won't be possible. We do want to make this possible. So this is going to be possible, and then this here. Right, so that means we don't actually have to look at the last row. The reason I don't want to look at the last row is because like when we do a +1 here, we have to check for the bounds. So I think we can just get rid of it actually. Yeah, so we have the two cases here. So let's deal with the easier case first. So dp I plus 1 j plus 1 is going to be equal to the minimum of itself, or it should equal the position of ij, because we are adding a character already. For this one, we do want to add a character. Right. Oh, actually, we should get position first. So position equals get position. What do we need again? We need the char. So that will be which row we are on right now. Which column we are on right now. So that will be the char. The index is going to be ij. So you just want to look for that. Oh wait, actually, when we find the position, yeah, when we find the position, we actually want to add 1 to it, because so like let's say we find the position like as 3 here, but that means we are going to use this, right? So we should go to the next one. Yeah. So we'll get the position here. Of course, a position only if position is not like infinite that you want to actually do something here. So that would be j plus 1. We want that to be equal to the position, I think. Wait, actually. Yeah, okay, we can just do like the minimum of, dpi j plus 1 and position. So we can just do that there. And we don't need that anymore. So I think that's our dp. So now we want to loop through the last column. Plus 1. So if dp, we want the last we want the row, but we want the last column, so we can just do that. If it is not equal to infinity, well, that means we can return I, because that's the number of characters added, and we're guaranteed that this is going to execute, because I'll return -1 outside, because I think it will return an error. Yeah, so this will execute because like we can technically just add the whole string at the front. Output 2. Oh, we want to return the actual string. That would be a lot more annoying actually. Yes, that would be quite annoying. But we do get the correct output here. So we are adding just 2 characters. Wait, are we? So string 1 is this. We added C at the front. So we're not actually adding that many. Okay, let's print out dp for now. See where we went wrong. So dp. So what do we have here? We have yeah, so that seems correct. 0, 4. Why is it 4 here? There should be 1 because wait, so this 4 means like it went this way, but what about here? Like, shouldn't it look at the horizontal one? So get pause. Did I mess up something here maybe? dp ij, so that will be the position. Maybe let's not do the +1 up here. I think that could be a bit messier. Let's do +1 here. So we want to find the position. So when we're looking at the when we're looking at A, so dp00, wait, dp01 should, oh, is this j plus 1? Cause yeah, this is j plus 1, right? Yeah, I think so. Because we have to look at the next character. But like, if we're just doing j, we're only looking at the current character, which is not what we want. I think now it should be correct. Yeah, 0, 1, 2, that looks correct. 0, 1. That is a bit off from whatever I have. But let's see, maybe I just missed a case. So this would be 1, 2, 0, 1, 2. This would be a second column, second entry. So it would be this thing here. Wait, you can do. Yeah, that shouldn't be 1 though. Yeah, so infinity 0. Yeah, why is that 1 there? Oh, is it going down from this way? Because we used an A here. Right, but then like we are adding a B. So we are adding a C and adding a B. And we can reach 2 okay, yeah. So that is 1. That is 1. Yeah, so our algo is correct. Just have to find a way to actually generate the string now. So how do we want to go with that? Hmm. Right, yeah, let's go back to the drawing board. So we want to see where we, like, which path we took to get here, right? I think. So if we do that, well, the path can either go up or that way. If they're the same, path, it doesn't really matter which path you choose. So you just want to, yeah. So I think like whenever you are updating the value, you want to like have an edge there. And then we can just like look back from there to see like where we are actually putting the characters in. So in this case, like we reach here, for B, our path is not adding a character B. We are finding a character B here. For I guess this is not for B, right? This is Wait, no, this is for finding B. Yeah, it is for finding B. And then and then we are actually using this path because like these two paths both goes here, right? But then wait, actually this returns infinity, so it doesn't actually update the value. But this line does update the value to be 1 because like we are adding a C at the front and then we find an A here. So that means like we are like finding an A is the optimal solution. And then, well, obviously for C, we do have to add that character because like imagine we have like something here. Okay. Right, so we need to generate a graph. Basically, that means. Or we can just store the predecessor. I guess we can store which way it comes down from, right? Like that would be a viable solution as well. Yeah, I think we just need a predecessor or something. So we have predecessor. So pred. How do we want to store this? Do we want for each entry a path? Or wait, actually we don't need that, right? So we want to find the first position, and then we want to loop backwards. Do you want to point from 0? Actually, we can also point from this point on. To be honest, yeah. Is it possible to also? Yeah, I'm just thinking of a nice way to do this because this is very tedious. So we have a 2 here that connects. Yeah, honestly, like finding this position. But then, yeah, the other question is how do we know where we are putting the character? I think that will be like we can solve that by finding like what character, like when we add a character, what position it is. So like if the position is 0, that means we want to insert a character at 0, right? Yeah, I think we can just use the normal inserts, I think. Yeah, so like there's a OM method for strings that usually are too slow to use, but like in this case it would be n squared, so more or less should be fine. Yeah, so we can look here. Yeah, so whenever whenever the path goes up, we want to add the current character like on our string one's position. And like when we add C here, I think it should push everything to the right, if I'm correct. Yeah, the thing is we still have to find the path here. So hmm. Oh yeah, let's rub this out. This should be infinity. So let's get rid of that. Yeah, so whenever we update it, well, I guess there are only two possible paths. So either it comes from like diagonally or it comes horizontally. So we can do something like true for diagonal, false for horizontal, or something like we will do constants. So diag, you set it as 0, hori, you set it as 1, empty, we'll set it as 2. So again, we want something exactly that looks like this, but then we set it as empty here instead. Right. Yeah, I guess like for this case, because we wouldn't actually have a path, right? Oh wait, we can set a path there. It should be simple enough to do that. So predecessor. So the pred of 0, 0 is going to be a hori, because we are not actually adding anything. But then the pred for 1, 0 would be diagonal. And then here, so when we do the min, I guess we can do something like if pos plus 1 is smaller than dpi j plus 1, we want to replace that. So we want to replace dpi j plus 1 with pos plus 1, and this is horizontal, right? So we want to set what do we want to set? Oh, we want to set predecessor of I and j plus 1. So it'd be horizontal. Right, and then we do the same thing here. So if I plus 1 j plus 1 is just say if dp I j is smaller than that, we want dp I plus 1 j plus 1 to be coming from the diagonal, and then you just set this to dpij. Yeah, so I think that should be correct now. And now we want to find the first position. So start will be yeah, let's do like start x, start y, start row, start col, maybe better. Yeah, let's do that. So the starting row is going to be starting row. Well, we know what starting column is. So I think let's just set starting row as that for now. Again, we are guaranteed that this is going to trigger, right? So we equal to I, and then we just break out of it. The starting column is definitely the last one, so that will be the length of string 2, -1. Yeah, I think we want the result string. So result string, it should be string 1 first. I think we might need to get a copy of it, right? Wait, do strings? I'm pretty sure strings, like, it references the same string, so we shouldn't use string 1. Whatever. This is just fine. So let's do that, and then so we should have while. Yeah, we should have while start C. Just do RC actually. So while maybe row column. Column is greater or equal to 0. So every time we move, we are guaranteed that we move to the previous column, right? So we can just use that as a check. So if predecessor of row column, well, also we are guaranteed that, like, if we can reach that means there is a valid path, and that means we are not going to see any empty cases. So if it is if it is horizontal, we just don't have to do anything. Oh, if it is horizontal, we do actually have to do one thing, which is decrement column. Else, so that will be if it is diagonal, we want to decrement column, decrement row as well, but we also have to like when we are doing a diagonal. So for diagonals, like those should be the same. So like if this is the minimum, right? Like it should be like they should have the same value, because like we're doing minimum. So that means like we can use this value, and then we just want to insert the character that we added. So that would be like B, the character we added here. Oh yeah, the character we added here, we just want to insert it at this position here. Yeah, okay, yeah, that should be correct. So we want rest string insert so where do we want to insert it? We want to insert it. Wait, I think like we have to like first of all do which character to insert first. So that will be string to column, and the position we want to put it in is going to be dp row column. So dp row column string to column, and then at the end we just return rest string. There might be some bugs, but there's no attribute insert. I'm just going to quickly check that actually. There's no insert. Okay, I need to search up that thing first, so give me a second. so we have Python insert one character. Oh, you have to create a new string, but I think there's a method, right? Let's see, insert one character method. Using list and insert function. First oh, okay, so insert is only for it's only for list. Just do that then. So turn that into a list, and then we insert it. At the end, we just do dot join. Just join them back together. String object cannot be interpreted as an integer. Does that mean I have it swapped? Let me Python list insert at index. So it is saying, yeah, position first, and then the character. Yeah, nice. That looks promising. Oh no. What is wrong here? I am adding 2 characters. So the first one would be B B B A A A B A. Second would be B B A. Wait, B B A B A. Right. So something is messed up here actually. So I did get the correct number of characters we have to add, but not the actual position. Well, that's not good. Let's think about this. So BBABA. So it is adding an A here for some reason. Could it be my path being wrong somehow? Okay, let's use the test case. BBBAABA. Right. Maybe we can like print out like which character it is inserting and where. So we can do print so I can print that. So it actually inserted. Wait. Yeah, these are the same length, right? Yeah, 6, 6, 9, 11, 3, 6, 9, 11. Yeah. So we inserted a B at 7, and then it inserted another B at 7. So 0, 1, 2, 3, 4, 5, 6, 7. Huh. Wait, so the string 1 is 0, 1, 2, 3, 4, 5, 6, 7. That means this character is the 7th character, right? I set the insert function. Oh, what is the issue here? Yeah, shouldn't it add it at the end? Yeah, it should add 2 B's at the end. Oh, is it because when we add characters, the whole thing shifts? Maybe that's the reason. Yeah, I think the whole thing shifts. So when you add a character, like when you have to add the same character, like at the same position twice, uh, you have to increment. Yeah, I think that's the issue, right? So like right now, it does push a B. Wait, but then on my actual answer, I have an A at the end, which is very strange. So it should push a B here. Wait, it does push a B here actually. So it pushes two B's. Wait, so 0, 1, 2, 3, 4, 5, 6, 7. Yeah, so the A is going to get shifted backwards, but it should have yeah, okay, it is actually doing what it is intended, but for some reason the answer is actually not correct. So that means my algo has some flaws in it. And when we add an A here, well, what does that actually cover? Hmm. 7B, 7B, 1A. I might just print out DP and so we can do for I in range DP, just print DPI, and then for that we're gonna print predecessor like this. This cannot be an integer length. We're getting cooked by this question. Let's see. So this one, it uses the characters. So it would be like string 1, string. Why is this 0 there? So 0, 0, 0. Oh, I think we have to add one here, right? Forgot a comma. Oh, oops. Okay, yeah, I just forgot. Well, like when you get a position, it tells you the location of the character, but then you have to move forward once. So yeah, that's my bad. I think now it should work. I think, hopefully. And nice. Wow, this question is hard. Definitely not easy at all. Like the logic, like, 2D DP array. But yeah, honestly, like I want to give a tip on like DP array. Like if you're still here, like I probably have taken like almost an hour to do this question. Like for DP, you really want to find the correct state first, and like when you find the state, you can kind of calculate how, like, what is the time complexity of your algorithm as well, and the correctness of it. Like you also want to exhaust all the different cases. So like for our example, it will be like finding the next character, and adding the next character. Also, what is this function here? Does it? Oh, okay, it tells. Yeah. So obviously the algorithm is n squared here. So yeah, very tough problem, but we got it done. So thanks for watching, and I'll see you tomorrow. Bye.